Good morning, class. I am your teacher for today. My name is Mr. Romulo A. Ato Jr. For this morning, we're going to have our Mathematics 9, Module 2, Week 2, 4th quarter, with the topic Trigonometric Ratios of Special Angles. How are you today, class? I hope that all of you are okay today. Let's have our Bible verse for this morning from the book of Galatians 6:9. And lead us not grow weary while doing good, for in due season we shall reap if we do not lose heart. So in this pandemic time, let's keep on following the minimum health protocols, then praying to God that this crisis we are facing right now will be over soon. So our lesson for this morning is about trigonometric ratios of special angles. Our objectives: state the trigonometric ratios of special angles and find the trigonometric ratios of special angles. Let's recall. Last time, we discussed on the 6 trigonometric ratios, namely the sine, the cosine, the tangent, the cosecant, the secant, and cotangent. So this time, let's apply what you have learned last time. So we have to find the value of 6 trigonometric ratios of the given acute angle of the triangle. So we have our acute angle, which is theta. Then in a triangle, we have 61 for the hypotenuse, 60 for the opposite side, and 11 for the adjacent side. Now, let's find the 6 trigonometric ratios of theta. For sine theta, we have opposite over hypotenuse equals 60 over 61. Cosine theta, we have adjacent over hypotenuse equals 11 over 61. Tangent theta, we have opposite over adjacent equals 60 over 11. Cosecant theta, we have hypotenuse over opposite equals 61 over 60. We have secant theta, we have hypotenuse over adjacent 61 over 11. And we have cotangent theta, we have adjacent over opposite side equals 11 over 60. Let's have letter B. So we are going to find again the value of 6 trigonometric ratios of the given acute angle of the triangle. So in this case, our acute angle is alpha. And we have 3 as the adjacent side, 5 as the hypotenuse, and we have the opposite side, which is missing. Now, we're going to find the opposite side of alpha using Pythagorean theorem. We have b is equal to the square root of c squared minus a squared. B represent as the opposite side, c represent as the hypotenuse, and a represent the adjacent side. So we have b equals the square root of 5 squared minus 3 squared. And we have b equals the square root of 5 squared, which is 25, minus 3 squared equals 9. Then we have b equals the square root of 25 minus 9. We have the square root of 16. And the square root of 16 is 4. Therefore, our b is equal to 4. Then, we have the opposite side of alpha is 4. Next, let's substitute the solved values in our triangle. So we have 4 as the opposite side, 3 as the adjacent side, and we have 5 as the hypotenuse. So now, we can now find the trigonometric ratios of alpha. We have sine alpha equals opposite side over hypotenuse is 4 over 5. Cosine alpha equals adjacent over hypotenuse is 3 over 5. Tangent alpha equals opposite side over adjacent equals 4 over 3. Then we have cosecant alpha equals hypotenuse over opposite side is 5 over 4. Secant alpha equals hypotenuse over adjacent is 5 over 3. Then we have cotangent alpha equals adjacent over opposite side is 3 over 4. Let's understand. What can you say about the two figures? What are the names of these figures? Okay, we have 45 degrees, 90 degrees, right triangle, and the blue one. Or isosceles right triangle in the sense that two legs in 45 degrees, 90 degrees right triangle are equal. Then we have 30 degrees, 60 degrees, 90 degrees right triangle in the red one, and they are special right triangle. So let's have the trigonometric ratios of special angles. Trigonometric ratios of special angles are ratios of trigonometric functions of 45 degrees, 90 degrees, and 30 degrees, 60 degrees, 90 degrees, special right triangles. So let's have the 45 degrees, 90 degrees right triangle. Let's have the measurement. The hypotenuse is square root of 2 times the measurement of each leg. So our leg is x, therefore we have the hypotenuse as x square root of 2. Next, let's have the measurement of 30 degrees, 60 degrees, 90 degrees right triangle. The hypotenuse is 2 times the measurement of the shortest leg or leg opposite to 30 degrees. So we have the shortest leg as x, then we have the hypotenuse as 2x. Next, the longer leg or leg opposite to 60 degrees is square root of 3 times the measurement of the shortest leg. So if we have the shortest leg as x, therefore the longer leg in 30 degrees, 60 degrees, 90 degrees right triangle is x square root of 3. Next, let's find the trigonometric ratios of a special angle. Let x be the length of each leg of 45 degrees, 90 degrees right triangle. Find number 1, sine 45 degrees, number 2, cosine 45 degrees, number 3, tangent 45 degrees, number 4, cotangent 45 degrees, number 5, secant 45 degrees, and number 6, cosecant 45 degrees. Number 1, sine 45 degrees. For sine 45 degrees, we have opposite side over hypotenuse. So we have x over x square root of 2. Simplifying, we have 1 over square root of 2. Then we have 1 over square root of 2 times the square root of 2 over square root of 2 by rationalizing the denominator. Rationalizing the denominator is used when we have radicals in the denominator. Then we have square root of 2 over 2. Hence, our sine 45 degrees is square root of 2 over 2. Next, we have number 2, cosine 45 degrees. Cosine 45 degrees is adjacent side over hypotenuse. So from the figure, we have x over x square root of 2. We simplify, we have 1 over square root of 2. Again, we have a radical in the denominator. Then we have 1 over square root of 2 times the square root of 2 over square root of 2 by rationalizing the denominator. So we have square root of 2 over 2. Therefore, cosine 45 degrees is square root of 2 over 2. Then let's have tangent 45 degrees. Tangent 45 degrees equals opposite side over adjacent side. So from the figure we have, the opposite side is x over the adjacent side is x. So we simplify, we have 1. Therefore, tangent 45 degrees is equal to 1. Next, let's have cotangent 45 degrees. Cotangent 45 degrees is equal to adjacent side over opposite side. From the figure we have, adjacent side is x and opposite side is also x. We simplify, we have 1. Therefore, cotangent 45 degrees is equal to 1. Then number 5, we have secant 45 degrees. Secant 45 degrees is equal to hypotenuse over opposite side. So we have x squared of 2 as the hypotenuse over x as the opposite side of 45 degrees. We simplify, we have square root of 2. Hence, we have secant 45 degrees equals square root of 2. Then we have the cosecant 45 degrees. Cosecant 45 degrees equals hypotenuse over adjacent side. So in the figure we have x squared of 2 as the hypotenuse over the adjacent side which is x. So we simplify, we have the square root of 2. Therefore, cosecant 45 degrees is square root of 2. Now, let's have the 30 degrees, 60 degrees, 90 degrees right triangle. Let x be the length of the shortest leg of 30 degrees, 60 degrees, 90 degrees right triangle. For A, we're going to find number 1, sine 30 degrees, number 2, cosine 30 degrees, number 3, tangent 30 degrees, number 4, cotangent 30 degrees, number 5, secant 30 degrees, number 6, cosecant 30 degrees. So let's have sine 30 degrees for number 1. Sine 30 degrees is equal to opposite side over hypotenuse. Then we have x over 2x. Simplifying, we have 1 over 2. So therefore, our sine 30 degrees is equal to 1/2. Next, let's have cosine 30 degrees. Cosine 30 degrees equals adjacent side over hypotenuse. Then we have x squared of 3 as the adjacent side over 2x as the hypotenuse. Simplifying, we have square root of 3 over 2. Hence, our cosine 30 degrees is square root of 3 over 2. Number 3, we have tangent 30 degrees. Tangent 30 degrees is equal to opposite side over adjacent side. Then we have x over x square root of 3. Then, simplifying, we have 1 over square root of 3. So we have radical in the denominator. Then we have 1 over square root of 3 times the square root of 3 over square root of 3 by rationalizing the denominator. Again, rationalizing denominator is used when simplifying radical expression in the denominator. So therefore, we have square root of 3 over 3. Tangent 30 degrees is square root of 3 over 3. Next, let's have cotangent 30 degrees for number 4. Cotangent 30 degrees equals adjacent side over opposite side. So from the figure we have adjacent side equals x squared of 3 over the opposite side as x. So we simplify, we have square root of 3. Therefore, cotangent 30 degrees is the square root of 3. Next, let's have second 30 degrees. Second 30 degrees equals hypotenuse over the adjacent side. Then we have 2x over x square root of 3. We simplify, we have 2 over square root of 3. Again, we have radical in the denominator. Then, we have 2 over square root of 3 times square root of 3 over square root of 3 by rationalizing the denominator. Then we have 2 square root of 3 over 3. Therefore, second 30 degrees is equal to 2 square root of 3 over 3. Let's have number 6, cosecant 30 degrees. Cosecant 30 degrees equals hypotenuse over opposite side. Then we have 2x over x. Simplifying, we have 2. Therefore, cosecant 30 degrees is equal to 2. Let x be the length of the shortest leg of 30 degrees, 60 degrees, 90 degrees right triangle. Then find number 1, sine 60 degrees, number 2, cosine 60 degrees, number 3, tangent 60 degrees, number 4, cotangent 60 degrees, number 5, secant 60 degrees, and number 6, cosecant 60 degrees. So let's have number 1, sine 60 degrees. Sine 60 degrees equals opposite side over hypotenuse. Then we have x square root of 3 over 2x. Then we simplify, we have square root of 3 over 2. Hence, sine 60 degrees is square root of 3 over 2. Let's have cosine 60 degrees. Cosine 60 degrees equals adjacent side over hypotenuse. Then we have x over 2x. So we simplify, we have 1/2. Therefore, cosine 60 degrees is equal to 1/2. Number 3, tangent 60 degrees. Tangent 60 degrees equals opposite side over adjacent side. Then we have x square root of 3 over x. We simplify, we have square root of 3. Hence, tangent 60 degrees is equal to square root of 3. Number 4, cotangent 60 degrees. Cotangent 60 degrees is equal to adjacent side over opposite side. From the figure, we have x as the adjacent side over x square root of 3 as the opposite side of 60 degrees. Then, simplifying, we have 1 over square root of 3. Again, we have radical in the denominator, so we simplify. So we have 1 over square root of 3 times square root of 3 over square root of 3 by rationalizing the denominator. Then we have square root of 3 over 3. Hence, our cotangent 60 degrees is square root of 3 over 3. Number 5, secant 60 degrees. Secant 60 degrees is equal to hypotenuse over adjacent side. Hypotenuse is 2x over the adjacent side, which is x. We simplify, we have 2. Hence, our secant 60 degrees is equal to 2. Number 6, cosecant 60 degrees. Cosecant 60 degrees is equal to hypotenuse over opposite side. From the figure, we have 2x as the hypotenuse over x squared of 3 as the opposite side. Then simplifying, we have 2 over square root of 3. Then, we have 2 over square root of 3 times square root of 3 over square root of 3 by rationalizing the denominator. Then, we have 2 square root of 3 over 3. Therefore, cosecant 60 degrees is equal to 2 square root of 3 over 3. Now, from the answers that we got, we have the table of trigonometric ratios of special angles. Let's check the trigonometric ratios of special angles using our scientific calculator. So before we proceed to computation, we're going to set up our scientific calculator. So we have set it to degree mode. Click S to D or X to E. In some calculator like Casio, you have the function there which is S to D. That is standard to decimal. If you do not want to have an answer with decimal, we're going to click or press that button. For trigonometric reciprocal functions like cotangent, secant, and cosecant, use the fractional form B over C. Because we do not have a reciprocal function like cotangent, secant, and cosecant in our calculator. So for cotangent, you are going to have 1 over tangent. For secant, you have secant to 1 over cosine and cosecant to 1 over sine in your calculator. Now let's check the trigonometric ratios of special angle using a scientific calculator. For sine 30 degrees, we have 1/2. For cosine 30 degrees, we have square root of 3 over 2. For tangent 30 degrees, we have square root of 3 over 3. For cotangent 30 degrees, we have square root of 3. Secant 30 degrees is equal to 2 square root of 3 over 3. And for cosecant 30 degrees, we have 2. Then let's have the 45 degrees angle. Sine 45 degrees, square root of 2 over 2. Cosine 45 degrees, square root of 2 over 2. Tangent 45 is 1. Cotangent 45 is also 1. Secant 45 degrees is square root of 2. And also for cosecant 45 degrees, which is square root of 2. Then let's have the 60 degrees angle. Sine 60 degrees is square root of 3 over 2. Cosine 60 degrees is 1/2. Tangent 60 degrees is square root of 3. Cotangent 60 degrees is equal to square root of 3 over 3. We have secant 60 degrees equals 2. And we have cosecant 60 degrees equals 2 square root of 3 over 3. Let's have illustrative examples. Example number 1. Fill in the number or the expression that will make each statement correct. Letter A. Sine blank equals 1/2. Correct. We have 30 degrees. B. Tangent 45 degrees equals? Correct. 1. Let's have letter C. Secant blank equals 2 square root of 3 over 3. Good job. That is 60 degrees. Let's have example number 2. Evaluate. When we say evaluate, you are going to find the value of the given expression. A. Sine 30 degrees plus cosine 60 degrees equals? So we have the solution. Sine 30 degrees plus cosine 30 degrees equals sine 30 degrees equals 1/2 plus cosine 60 degrees equals 1/2. 1/2 plus 1/2 equals 1. Hence, sine 30 degrees plus cosine 60 degrees equals 1. B. Sine 45 degrees over cosine 45 degrees plus secant 45 degrees. We have the solution. Sine 45 degrees over cosine 45 degrees plus secant 45 degrees. So we have square root of 2 over 2 for sine 45 degrees over square root of 2 over 2 for cosine 45 degrees plus 2 from secant 45 degrees. So we simplify square root of 2 over 2 divided by square root of 2 over 2 is equal to 1 plus 2 equals 3. Hence, sine 45 degrees over cosine 45 degrees plus secant 45 degrees is equal to 3. Sample number 3. Complete the following statements. Letter A. If theta equals 60 degrees, then cosine theta equals, you're correct, 1/2. B. If secant theta equals square root of 2, then theta equals, very good, 60 degrees. Let's apply. Complete the trigonometric table of special angles. So you're going to look for sine 30 degrees, tangent 30 degrees, cosecant 30 degrees, cosine 45 degrees, cotangent 45 degrees, secant 45 degrees, sine 60 degrees, tangent 60 degrees, cotangent 60 degrees, cosecant 60 degrees. I will give you 30 seconds to complete the table. Let's have the answers. For sine 30 degrees, we have 1/2. Tangent 30 degrees, we have square root of 3 over 3. Cosecant 30 degrees, we have 2. Then for cosine 45 degrees, we have square root of 2 over 2. For cotangent 45 degrees, we have 1. Then for secant 45 degrees, we have square root of 2. For sine 60 degrees, we have square root of 3 over 2. For tangent 60 degrees, we have square root of 3. For cotangent 60 degrees, we have square root of 3 over 3. And for cosecant 60 degrees, we have 2 square root of 3 over 3. Good job! Now let's analyze. Fill in the blanks. For letter A, cotangent blank equals square root of 3 over 3. For B, cosecant 30 degrees equals blank. For C, tangent blank equals square root of 3. For D, sine 45 degrees equals blank. For letter E, cosine blank equals square root of 2 over 2. I will give you 30 seconds to answer these exercises. Okay, let's have the answers. Letter A, cotangent blank equals square root of 3 over 3. The answer is, good job, 60 degrees. B, cosecant 30 degrees equals, very good, 2. For C, tangent blank equals square root of 3. The answer is 30 degrees. Letter D, sine 45 degrees equals, correct, square root of 2 over 2. And for letter E, cosine blank equals square root of 2 over 2 is, correct, 45 degrees. Remember class, trigonometric ratios of special angles are ratios of trigonometric functions of 45 degrees, 90 degrees, and 30 degrees, 60 degrees, 90 degrees, special right triangles. Now, are you ready for a quiz class? Let's try. Use the trigonometric values of special angles to simplify the following. Number 1, cosine 60 degrees, plus secant 60 degrees equals blank. Number 2, sine 45 degrees plus cosine 45 degrees equals blank. Number 3, secant 60 degrees plus cosecant 30 degrees minus cotangent 45 degrees equals blank. Number 4, cotangent 60 degrees times cosecant 60 degrees equals blank. Number 5, cosecant 30 degrees over secant 60 degrees plus tangent 45 degrees equals blank. And we have the answers. Number 1, 5 over 2. Number 2, we have a square root of 2. Number 3, 3. Number 4, 2 over 3. Number 5, 2. For your assignment class, in your Math 9 notebook, list down at least 5 real-world applications of trigonometry. Then, have always with you your scientific calculators for our cycle drills. And that's all for today. This is your teacher, Mr. Romulo A. Ato Jr. Thank you.